A very good day, everyone. I've called this session REST API, the Paladin of modern applications, because today if you want to build modern apps, and I don't mean just nice user interface that are typically up to front-end designers, we are developers and software architects. I mean state-of-the-art, scalable, robust 3-tier apps, then you must go for REST API. If you have some experience with this, just close your eyes for a sec and try to imagine what the software landscape would be without API. I think it's pretty hard to imagine. If you don't have, instead, I'm gonna give you a short introduction so you can take it as a background knowledge. So modern apps often go hand in hand with cloud applications. The pandemic has changed significantly the habits of developers and users. It has accelerated the digital transformation because the difficulty in using client-server with deployment on-premise. And even if client-server apps continue to work through Citrix and VDI architectures, they are apps not built to expose data with performance because not designed for cloud. They have high costs for terminal licenses, not to consider the fact that running client-server on VDI doesn't scale up because multiple and monolithic instances of same process are allocated. Okay, short disclaimer. And let's have a look at the session agenda. I will start introducing the concepts that lie behind 3-tier app architecture and the role of REST, a software architecture that imposes conditions on how API should work in complex network like the internet. Then ASP.NET Web API, that is a framework for building HTTP services that can be accessed from any client, including browsers and mobile devices. It is an ideal platform for building RESTful applications on the .NET framework. Then I'll discuss what connection pooling is, why we need it in REST API, and how it works. I will also discuss how you can set up cache names dynamically instead of having the API to connect to a fixed cache name. So here we have an API, not a cloud app, so it may be a little bit tricky. Next, I want to talk about my own experience in integration between REST API built in SnapDevelop and UI development frameworks. In other words, what I had to do in order to adapt in SnapDevelop Web API projects and the lesson that I learned to fulfill those best practice and conditions on how API should work. I will demo a web app that I developed with backend in SnapDevelop, datastore, and frontend in JavaScript HTML. And then I'll derive some conclusions. A few words about myself. I'm an Appian MVP. SoftP is Appian certified partner for product sales in Italy and Spain, and it's a privilege for me to have a solid long-term collaboration with this company. I've used Power Builder since version 4.0 and Power Server ever since. Recent projects, as you can see, also very much related to this topic, to the topic of this presentation, because recently I've grown up experience into web frameworks to design plugin-free user interface as a cross-platform alternative to Power Builder and Power Server cloud frontends. And namely, I've been working with Vue.JS and Quasar in order to consume REST API built with SnapDevelop. 3-tier architecture has a broader concern. It's about organizing the code in the whole application. A 3-tier app architecture is a modular client-server architecture that consists of presentation tier, an application tier, and a data tier. The data tier stores information, the application tier handles the logic, and the presentation tier is a graphical user interface. The 3 tiers are logical, not physical, and may or may not run on the same physical server. Examples of 3-tier apps are web apps, usually accessible via web browsers. In Power Builder, we build instead cloud apps, whose infrastructure and data are not only accessible through the web browser, but also downloadable. So, all cloud apps are web apps with additional features. A key difference between cloud and web apps is architecture. A web application must have a continuous internet connection to function. On the other hand, a cloud app performs processing tasks on a local computer. A very popular architectural pattern is Model View Controller, MVC, which is also based on three-layer architectures and its three main logical components, the UI, the logic, and the data, defining the so-called separation of concerns. MVC is used to create websites. MVC divides the UI part into three components. The view, it's a kind of UI of the UI, the model to handle the data, and controller to handle the logic. In this case, the controller usually returns a view, for example, HTML response to browser request. Web API, which are one of the goals of Power Builder development today, on the other hand, are usually made to be consumed by others. But the main difference is topological. It comes from how the tiers communicate with each other. The three-tier architecture is linear. The client tier never communicates directly with the data tier. In a three-tier model, all communication must pass through the middle tier. On the other hand, in the MVC architecture is triangular. The view sends updates to the controller updates the model, and the view gets updated directly from the model. In recent years, it has become clear that HTTP is not just for serving up HTML pages. It is also a powerful platform for building APIs. Using a handful of verbs, get, post, and so forth, plus a few simple concepts such as URI and headers. Since plenty of APIs are built to operate over the internet, it's no wonder they have adopted HTTP as their standard protocol. Why? Because most developers are familiar with the protocol, so it's easy to use, update, and scale. It requires little processing by the apps, so it's faster than other protocol. Its flexibility means that API built on it can accomplish a wide variety of objectives, and responses can be cached, meaning that repeated commands are processed faster. And the valid HTTP request has four components: a URL, uniform resource locator, a method, a list of headers, and the body. While in general Web API may rely on multiple communication protocols like SOAP, XML RPC, JSON RPC, which are protocols that are certainly built on top of the HTTP, but represent one extra layer in communications, the REST API typically uses HTTP directly, facilitating simple design and efficient data transfer. RESTful terminology are often synonyms in most of the conversations, but there exists a key difference. REST is a software architectural style used to create stateless, reliable, multi-tier application. It is a short for representational state transfer, meaning that the server will respond with a representation, the state of a resource. For example, HTML, XML, or JSON document. RESTful is related to the design of HTTP-based API with get, put, post, delete HTTP methods used for reading, updating, creating, and deleting resources. And why today REST API are so important? Because systems that implement them can scale efficiently because REST optimizes client-server interaction. Stateless communication removes server load because the server does not have to retain past client request information. And well-managed caching, partially or completely, eliminates some client-server interactions. ASP.NET Core Web API combines MVC, that typically returns a view, HTML, and Web API, that is designed to return REST responses, typically a JSON object, but not always. ASP.NET Core Web API merges the two into the same controller and simplify HTTP programming. Either you use Visual Studio 2022 or Appium SnapDevelop, you can find a template for creating ASP.NET Core app with a controller for RESTful HTTP service. So that is the icon in both IDE to build a project template for creating an ASP.NET Core controller for RESTful HTTP services. The schema here on the right from appium.com shows that when the client app sends a user request, a URL to the web API, the API controller class handles the request and calls the method in the service class to perform the business logic and data operations. So the controller is responsible for initial processing of the request and returning the processing result. A controller does not include data access or business logic. It invokes the services to perform data operations and business logic. The service instead is responsible for retrieving and creating data models from the data sources, executing application logic and operations. So the services are where the core business logic resides or is interfaced. A service typically separates an interface from the implementation of that interface. And the models, not shown in this simplified image, maps physical data into logical entities that become application objects in memory. So with this said, let's see how we can create our first ASP.NET Web API project in SnapDevelop in a few minutes without writing any line of code, thanks to the built-in right-click and wizards for automatic code generation provided by Appium SnapDevelop. So let me switch to my PB 2022 revision 2 machine. I just want to start from a data window built-in Power Builder and then show how to transform this data window into a fully fledged API featuring retrieval of data and also update of this data. Let me play with the list of departments that are available in the Power Builder demo database. So here you see I have a very simple data window, and it's very important to remember that the data window comes with update properties specifying which is the key column, what are the key modification, and the where clause for update and delete. So this information will be retained in C# when we're going to use C# data store. Let's go to SnapDevelop. I can create a new project and I will use the icon ASP.NET Core Web API to create an ASP.NET Core application with an example controller for RESTful HTTP service. Let me call this project Elevate and location and solution name. I want also to place solution project in the same folder. You can select among three types of template. Basic creates an empty project. A data store instead already creates some logic based on C# data store and then SQL model map. Target framework, Net 6.0 because 3.1 is obsolete. Authentication type to protect the API, to secure the API. I enable HTTPS and also the generation of the Swagger web page, Open API support, and click on Create. So a few seconds and then the project will be ready. Now, first step is to attach to this C# Web API solution my Power Builder workspace. So I'm going to select my workspace where I can find the department data window. If I right-click on the department data window, I can convert this object into a corresponding C# model. So in this panel, you see the data object name in Power Builder and then corresponding class that will be created in C#. Let's remove the D underscore, which is only part of the Power Builder naming convention. When ready, you can click on Export and the model will be created under the models subfolder. Export. All right. So in my C# project, model subfolders, I have the department class. So that basically is built on top of the data object. So the key column, department ID, department name, and the header ID. And here a number of annotation corresponding to the update properties of the data object that will be used later to generate the corresponding controller and services and prepare all the necessary operation to get, put, post, delete the resource. So from the department model, I can now generate or scaffold the service and the controller in order to have the three components that made up the web API. Click on this option, and here I see the window is twofold. On top, the service, which will use .NET Datastore and can also be created from three different templates. For Power Builder clients, which are aware of the data window object, so they can transfer back and forth to the API, not just flat JSON data, but an entire data window description with its metadata, primary buffer, delete buffer. Otherwise, for non-Power Builder client, in this case, the service will just return or receive JSON data, plain models, or any client to merge the two of them. So let's make it general, non-Power Builder client. The code can be asynchronous or synchronous. Asynchronous allows to avoid blocking calls. So whenever the service will interface, will send requests to the database, won't be blocked waiting for the database to answer, but it will get notified by a callback when the work is done. So let's place the service into the services subfolders and create a data context, which is the equivalent of the Power Builder transaction object. So let me call it SQL Anywhere data context, just to give a name. And I connect to my Power Builder DB demo 2022, create. Let's go for simple base class, don't use inheritance. And then the controller will be created based on the above service. And the controller class will be stored under the controllers subfolders. Okay, click on generate, download the .NET database driver and the DWNet Appian package that implements the C# data store. When done, you will see that also a controller class, department controller, is added to the controller subfolders, and into the services subfolders, I have the interface and the implementation. So let's see the results before discussing the code. Last step to do, open up the program C#, so that's the entry points. It's the equivalent of the Power Builder application object. And in here, I will do a couple of right clicks to inject the data context. So connect the database that I have specified in the configuration file and inject also the service class. So inject service, my department class. All right, so now the web API is ready. I can run it. And after the build, I will see that the API will start in console mode So the web container hosting the web API is started, and the Swagger page is also created. It shows that my API exposes a few endpoints to get to retrieve one department or to retrieve all departments, to post, one to create a new resource, a new department, and one to update an existing department and then delete. That's at least is the default list of routes created, but then later on in the presentation we will discuss about this endpoint. Just to make a little example from this Swagger page, I can execute, for example, the get department retrieve that will return the list of 5 departments. So that's the response. I can also directly in a browser call http localhost. Oh, it's running on port 7009, and then API department retrieve. Okay, so that's the JSON response. I can test get one. So if I know the ID, I can pass the ID in the endpoint, execute, and I will get department 100, that is research and development. Or I can also create a new department. For example, I create department with ID 600. In this case, I have to provide the payload for my post request. 600 is the ID, elevate department, and the header ID, for example, let's take this 501, same manager. Execute. Return code is 1. Application level response body is 1, meaning one row is created. The HTTP status code is 200, meaning the request is successful. And I can see that this new department is actually created by running again the get department. So execute again, and now I can see that the department 600 is part of my department table. All right, so fully fledged API in just a couple of minutes with no writing of a single line of code. Let's go back to presentation. And I want to talk now about connection pooling. It's known fact that database connections are expensive to create. So connection pools in API come into play when you have a large number of requests that generally take a short amount of time. You reuse a pure database connection in a new context to avoid the cost of setting up a new database connection for each request. In a cloud app, in API, we need to deal potentially with large number of sessions, large number of client requests, whereas the number of physical connections to the database may be smaller. That's why the pooling speed up performance and optimizes the request. Each physical database connection is cached in the pool when idle and used by any client when necessary. What happens when connection pool is full? If the maximum pool size has been reached and no usable connection is available, the request from the client app is queued. The pooler then tries to reclaim any connections until the timeout is reached, which by default is 15 seconds. If the pooler cannot satisfy the request before the connection times out, an exception is thrown. So this is how the connection pooling works. Why connection pooling? Its main purpose is to reduce the overhead in performing database connections and read-write database operation. At the most basic level, a connection pool is a database connection cache implementation. And of course, why is a kind of rhetorical question. If we analyze the sequence of steps that are involved in a typical database connection lifecycle, the reason should be clear because you need to open a connection to the database using the database driver first, then open TCP socket for reading and writing data, then perform the actual read and write data over the socket, and then close the connection and close the socket. It becomes evident that database connections are fairly expensive operation, and as such, they should be reduced to a minimum. And here is where connection pooling implementations comes into play. By just simply implementing a database connection container, a pooler, which allows to reuse a number of existing connections, we can effectively save the cost of performing a huge number of expensive database trips. And this boosts the overall performance of our database-driven applications. So now let's discuss the code, the C# code in our SnapDevelop Web API project. A standard way to use the connection pool is to instantiate a data context, a data context class in the program CS. So data context class contains the connection string information that is typically stored into the app settings JSON configuration file, and the methods for connecting to a database and manipulating the data in the database. Then each service, for example a department service class in the API project, can use a data context which is declared in the constructor via dependence injection, and use it for database operation. For example, create a datastore object and make it using that data context for the subsequent retrieve operation. So in this case, we have a fixed data context because whenever the web API is starting, the data context is of this type here. On the other hand, it can be a desirable feature to connect to different databases, to have the API to connect different databases. Although SnapDevelop doesn't offer code generation of this type, you can achieve the expected functioning schema with very little code. So the scenario is the client sends the cache name to the server API as an argument in the header. So let's say that we have a custom header called cache name, specifying the actual cache name to be selected from those one available in the API configuration file. Actually, you can also send it in the query string, but I'd rather avoid exposing this information. So for instance, get departments from cache name called cache A, a class that represents the data context factory in service in the API will retrieve this parameter from the request HTTP context and pass to the service class a data context of the type specified, among, of course, those available in the API app settings conf file. Say cache A that connects PBDemo, cache B that connects a second SAP database, and cache C that connects Microsoft Adventure Work database. In details, this is the code example. So box on the top, the Power Builder code, as easy as sending a GET request with a custom header cache name. Box at the bottom here, this two box needs a bit of explanation. You see at the beginning how the data context is set via the dependency injection. It's not used the typical add data context method, which is part of SnapObject's data package to make it easier to inject data context class. But here, with the classic way to inject another class in C#, the add scoped function. And the datacontext factory class access the HTTP objects in its constructor, and which is then used here below to extract the cache name header, then read the corresponding database connection string from the configuration file, and create a new data context instance for this cache name. So this way, the client can specify to what database send the actual retrieve. All right, this said, let me show where we are in this presentation. It's time now to move to the second part, where I want to talk about my own experience in integration between REST API and user interface. That is what I changed in SnapDevelop Web API projects to fulfill those best practice and conditions on how to build properly an API, a RESTful API. First off, endpoints. So SnapDevelop is a code generation. It's a great, priceless IDE that simplifies your approach to Web API. Whenever a controller is scaffolded from the service class, this action is a name that adds the function names to the routes. That is, in this employee resource, where SnapDevelop can create all routes to get, post, delete data, retrieve one, retrieve, update, update one, and so on are created. But this is not actually RESTful standard. You are not meant to expose the internal implementation to the front end. The HTTP verbs are enough for this, leading to a clearer and simpler list of endpoints where the only thing to repeat is the resource name, employee, 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 maybe the identity value as a parameter, the emp ID, but the operations are specified by the HTTP verb. Get to retrieve, put to modify, delete to cancel, post to create. So this worker page on the right shows one get with parameter to return a single employee row, put to modify a single employee row, get with no parameter to return all employees, etc. So first change is to get rid of the action and then solve conflicts, if any, in the routes using the same verbs. Next is the return type in post and put request. In other words, add a new record or modify an existing record. The controller returns, in this case, an integer, which is the return code of the C# datastore update function. On the other hand, it's best practice to return the actual resource being created or modified. So I would change the integer into the actual model, in this case employee. And this translates into a controller returning the employee model to the client, as well as, of course, the service class doing the same. Is the HTTP verb that specifies a given resource needs to be updated. It's again best practice to specify the identity value for the resource. In other words, the key value that identifies row being changed. This is a parameter to add the put route, and the controller receives this parameter, even though it may be available also in the body where the actual up-to-date resource is passed. And also, like described in the previous slide, don't forget to return to the client the modified resource, rather than just the return code of the update. So, transaction in this example. When you have a Power Builder data windows with multiple retrieval arguments, they are converted to multiple parameters in the route path. For example, a resource transaction needs two data window retrieval arguments, year and product ID. This path is not ideal. The UI developers prefer multiple parameters to be part of a query string, as in this example to the right. The endpoint is much clearer. So just API transaction. No extra mandatory arguments because year and product ID with this syntax, with this path would be required, would be mandatory. So if any, they are retrieved from the query string. And this is specified in the signature of the controller function thanks to the from query keyword. And this introduces the next change and the concept of surrogate key. A surrogate key is a unique identifier derived from the data itself. It often takes the form of a hashed value of multiple columns that will create the uniqueness constraint for each row. So it can be just a primary key made of multiple columns. So in this example, there is a resource of type transaction that is identified by date of the transaction, 15 January 2020, and then the customer ID and the product ID involved in the transaction. They are indeed the primary key in the physical table, and when you create a Power Builder data window, this results in 3 retrieval arguments. But when rendering a list in UI dev frameworks like React, Vue, Angular, it's very much recommended that you give the repeated element, for example in the for construct, a unique value as a key. And this helps these frameworks to optimize the rendering when adding and removing elements from the collection. Therefore, controller functions like retrieve1 or the delete by key, in this function, the surrogate key must be split in order to decode the individual values that are needed by the actual retrieve operation. So from the surrogate key, split up the string into the relevant arguments. And this argument will be passed to the service or merged when the surrogate key is returned by the models. So you may need in this SQL of the models to combine the arguments into one surrogate key. Alright, so with all this done, we are most likely ready to present the Swagger interface to the UI designer and have our application ready for a modern user interface and user experience. Because a modern, crispy, charming user experience increases usability, that is, increases the task success rates and efficiency, increases clarity of the application with the design as clear as possible so that users could not get confused. It creates delight because it maximizes user satisfaction when using the application and also improves familiarity. A visual design which is familiar to the users builds user trust and interest in the product. So the web app UI that I'm gonna demo in a few seconds is built on top of following development stacks: Vue.JS, that is an open source front-end JavaScript library for building UI and a single page application; Node.js, an open source JavaScript environment that consists of a runtime engine and package manager, so you can use a CLI and run the Vue application server; and then Quasar, that is a front-end framework with Vue.js components for responsive websites, and it gives out-of-the-box material design. It's a library with many UI components that are dedicated for Vue. And then VS Code is a modern open source IDE. That's of course is just one of the possible stacks. I gave a long step-by-step tutorial at Elevate 2020 on how to design cross-platform user interface based on these front-end development stacks calling REST API built in Appium SnapDevelop. At that time, I also tried to argument why Vue.JS rather than other framework, as Angular, React, Vue are common words, it's difficult to grasp their popularity from the Google Trends, though a good proxy for their popularity, I think, is the number of stars that their GitHub repositories get. So you can see from this graph, a sudden shift in the number of stars of Vue happened around mid 2016, and recently Vue has been up there with React among the most popular framework. Um, so here are a couple of screens of the app that I will demo in a second. Very simple in terms of functionality. It is a small CRM and sales app, but it features modern interface that displays data returned by the REST API with collapsible left side bar that extends and overlays with when you hover the mouse on an icon. Then the hamburger menu, um, selection bars, master and detail view with lists featuring built-in sorting and filtering, as well as client-side paging, automatic padding. You can also enable chips for showing recent screens and quickly move among them, or you know, material design buttons and profile icon. A lot of these modern widgets. And of course, same UI can become a native macOS application or a mobile app aware of automatic resize and orientation, and also widget components repositioning according to the screen size. So portrait rather than landscape. All right, so quick demo of the app. Let's switch again to the dev machine. And for the sake of completeness here, I have the remote server running the API directly from from SnapDevelop in console mode. So you can also see the network traffic. You can also see the old HTTP request coming from the client. So starting the front end. Login page is based on user and password, but only the first time because then a JWT token is generated by the API and sent during all subsequent requests. Each client request stores the token into the HTTP header for validation. And the Remember Me checkbox keeps this token stored on the client so the user doesn't need to type in again the login credential. Next, the API, the app is starting. It's a single page application, quite simple because it is a small app with usual list of customers, products, transaction and invoices. I'm running on my desktop, so there is plenty of space for the menu, for animation, and automatic resize with zero code. All is managed by the framework. By the way, adding picture support, since we are here on a product page, is quite straightforward. Once you have the product API, just need to add some more routes, one get and one post to download and upload pictures. Data grid sorting and filtering is built in, no need to code. Filtering is Excel-like with list of values that you can select or unselect. And quite charming, the feedback the user gets all over at each click or selection or mouse hover. And also the search as you type feature is very handy and can be applied to the entire data set regardless the column with focus. Of course, the framework allows easy build of native Windows app or Linux or Mac OS, as well as native app or web app for any mobile operating system. Let me show an example from an iPhone. So here a smaller screen, but automatic adapting to resolution and space. So here is the portrait, then sign in, same menu. I can also make it landscape with more space, resize the list, and scroll down to the detail. Make a change, show some pictures. All right. Conclusions. Um, we have been talking about 3-tier architecture. So modern apps are based on 3-tier architecture where the cloud is the typical infrastructures, applications send stateless requests to the API server, and perform processing tasks on a local computer. In SnapDevelop, you can build ASP.NET Web API projects, starting from Power Build data windows and also converting PowerScript into C Sharp thanks to the C Sharp converter, PowerScript converter built-in feature. Remember, RESTful API has strict standards and best practice, so you may need to adapt the code initially generated by SnapDevelop. That way, you're ready to present the Swagger interface to the UI developers and create component-based, beautiful user interface. For example, Vue.JS and Quasar can be one development stack. So go and be ready for refactoring unattractive, non-cross-platform legacy Power Leader applications into modern 3-tier cloud apps. Q&A time. Thank you very much for your attention.